working here like a research associate in the lab of Dr. Natuli. And today I will be the moderator, and I'm very pleased to introduce our speakers in the Cardiovascular Regeneration Conference. Our first speaker will be Dr. Cook. Dr. Cook was recruited to Houston Methodist since 2013. He is the chair of the Department of Cardiovascular Science and the director of the Center of Cardiovascular Regeneration in the DeBake Heart and Vascular Institute. He was trained in cardiovascular medicine and obtained his PhD in physiology in the Mayo Clinic. Later on, he joined Harvard Medical School and an assistant professor of medicine. Then, in 1990, he was recruited to Stanford University School of Medicine as an appointed professor in the Division of Cardiovascular Medicine and associate director of the Cardiovascular Institute. With a very successful career, he has published over 500 research papers, reviews, book chapters, and patents. He serves on national and international committees at the American Heart Association, American College of Cardiology, Society for Vascular Medicine, and the National Heart, Lung, and Blood Institute. Moreover, he has served as president of the Society for Vascular Medicine, as a director of the American Board of Vascular Medicine, and as an associate editor of Vascular Medicine. His talk today is called "You Are Only as Old as Your Endothelium: Role of Endothelial Homeostasis in Cardiovascular Health."
Thank you, Liliana. Thank you, Liliana, for that kind introduction. And thank you for joining us today at the Center for Cardiovascular Regeneration at the Houston Methodist Research Institute. I'm going to talk today about something that I have great interest in, endothelial health. And the endothelium is very important in cardiovascular disease. I don't need to tell this audience how important cardiovascular aging is. Atherosclerosis is a major manifestation of cardiovascular aging, and it's a major cause of death and disability in this country and in the world, by the way. Globally now, atherosclerosis is the major cause of death globally. So we need to do something about that. Stroke, heart attack, renal vascular disease, heart failure, these are all related to vascular diseases and primarily atherosclerosis. Vascular disease, atherosclerosis, typically begins with endothelial dysfunction. What do I mean by that? The endothelium is a single layer of cells. It's a monolayer. It's a diaphanous film of tissue that exerts tremendous control over vessel structure, vessel tone, and interaction of the vessel with circulating blood elements. By virtue of the panoply of paracrine factors that it produces, when the endothelium is not performing its job, that endothelial dysfunction leads to vasoconstriction, inflammation, smooth muscle cell proliferation, and thrombosis. These processes play a major role in vascular disease and in atherosclerosis. Now, when the endothelium is healthy, it is producing factors that preserve homeostasis, that keep the blood vessel open, that keep it from thickening, that keep circulating cells from sticking to the endothelium. One of the factors that plays a major role in endothelial health is nitric oxide. Endothelium-derived nitric oxide is a powerful vasodilator, arguably the most potent vasodilator made by the blood vessel. And it also has significant effects on the adherence of leukocytes to the endothelium, as Natuli can tell you. It has an effect on smooth muscle cell proliferation. It also affects platelet reactivity. Nitric oxide reduces platelet aggregation and platelet adherence to the vessel wall. In addition, nitric oxide opposes the expression of oxidative enzymes like NADPH oxidase in the vessel wall. And by virtue of that effect to oppose oxidative enzymes, it reduces lipid peroxidation, which is one of the causes of atherosclerosis. It's a simple molecule, nitric oxide, bimolecular molecule, but it exerts tremendous control over vessel health. Now, when the endothelium is not making sufficient amounts of nitric oxide, which happens in hypercholesterolemia, diabetes, hypertension, all of the things that cause atherosclerosis, the endothelium changes from something that's like Teflon that prevents cells from sticking to something more like Velcro by virtue of the fact that the endothelium begins to express adhesion molecules and chemokines that allow this process to occur. This process is the first observable event in atherosclerosis, which is monocyte adherence to the vessel wall, to the endothelium, and diapedesis into the vessel wall. The monocytes are being attracted by these adhesion molecules and chemokines that are expressed on the endothelium. The reason that those are being expressed is because lipid, oxidized lipid in the vessel wall is sensed by pattern recognition receptors on the endothelium as a foreign substance. So that triggers the endothelium to express the adhesion molecules and chemokines that allow the monocytes to enter and adhere. Now, to adhere and enter, rather. Now, once inside of the intima, underneath the endothelium, the macrophage go about their work, which is to scavenge abnormal proteins and particles, including oxidized lipid. Now, if there's a lot of lipid in the vessel wall, which happens in hypercholesterolemia, and people that have high cholesterol, the monocytes are very busy absorbing lipid and become foam cells. So these are cells that are grossly swollen with lipid. The macrophage have become foam cells, and it is the aggregation of these foam cells into lesions called fatty streaks that form the first grossly visible lesion in the vessel wall in people with, even in young people. You see these fatty streaks occurring. This is the first form of atherosclerosis, these fatty streaks. They tend to occur at bends, branches, and bifurcations of the blood vessel. Here you have areas of disturbed flow where you have vortices. These vortices of recirculation increase the interaction of lipoprotein particles with the vessel wall, monocytes with the vessel wall. In addition, in those disturbed flow regions, the endothelium changes. It becomes altered in its form and function and begins to express adhesion molecules. So even before the onset of these lesions, the endothelium changes. So Myron Cebulski had described these areas as sites of atheroprone. They're atheroprone sites in the vessel wall, meaning that they are susceptible to atherosclerosis because the endothelium has already changed. It's expressing adhesion molecules and chemokines even before the insult of high cholesterol or diabetes. So these are atheroprone areas because of the change in endothelial biology. The other thing that happens here, I'll show you in a moment, the endothelium ages faster here. So Chang and Hurley showed that the endothelium is proliferating more rapidly here. It's turning over faster. And we actually have sites of focal senescence in our body where we're aging faster. Just as sun-exposed skin ages faster, so too does the endothelium at sites of these disturbed flow. Now, as time goes on, if the person is not treated, if they remain hypercholesterolemic, diabetic, the lesion continues to grow. And you get these complex lesions in the center of the lesions in the vessel wall. By the way, you're looking at a coronary artery of someone who's met their demise through atherosclerosis. They had a myocardial infarction, a heart attack. And what you're looking at is a complex lesion that is in the later stages of atherosclerosis. You see in the center of this area a necrotic core. This is loaded with lipid